Hello everyone, this is a continuation video of grade 9 chapter 1 real numbers. So in this video we are going to see what are surds or radicals, then rationalizing factor, and then how to do the rationalization of surds with some example problems. Let's see what are surd or radicals. See, surd is nothing but I'm having some root x, and this root x cannot be simplified even further. Then I can say it's a surd. So this is what we are going to see in the definition. See, if x is a positive rational number, see what is inside the root, it's nothing but a positive rational number, and n is a positive integer. Where this n will be specified, so on the top of the root, this only will decide whether this is a square root or cubic root. If no number is presented on the top of the root, then I can say it's a square root. Or sometimes even we can have like this also. This is also square root, or this. Both are equal. So we will be having cubic root of x. That means in the place of n, if you have 3, I can say it's a cubic root of x. So they are pointing n over the top of the root. So n is going to be a positive integer, and the x, that means the number inside the root, is going to be of positive rational number. Then we can express this in a general form of nth root x, which is actually an irrational number, and even I can say this is a surd also. The another form of representing the surd is x to the power 1 by n. So I have given an example over here, which is nothing but cubic root of 6. In this, 6 is a rational number, positive rational number, and 3 is a positive integer. That's the reason this is a surd, and also this is an irrational number. And some example we have given over here, root 5. Is it possible to simplify this root 5 even further? No. That's the reason it is a surd. And see here, biquadratic root of 8. So actually my root value, n value is 4. Inside 8 is there. 8 is not a prime number. So I am just doing the prime factorization of 8. I will be getting 2 into 2 into 2. 3 2's are there. But here you have 4 in your nth place. So if there are 4 repetition numbers only, I can take it as a single number outside of the root. Since it doesn't have any 4 number repeated, I can't simplify this even further. So that's the reason this biquadratic root of 8 is also known as surd. And see here, cubic root of 20. So can we do the prime factorization for 20? 20 is 2 10 times and 2 5 times. So I can write this cubic root of 20 as cubic root of 2 into 2 into 5. See here, there are two factor 2 and 5, but both the factor are not having the repetition of 3 times. So that's the reason I can't take any number outside from the root. So I cannot simplify this cubic root of 20 further. That's the reason all these are known as surds. And see the next example, root 4. What is the value of root 4? It's 2. And see, cubic root of 27. So I can write this 27 by doing the prime factorization. You'll be getting 3 into 3 into 3. See here, this is a cubic root, and also inside the root we are having the repetition of one number for 3 times. So it's equal to 3. That's why we are getting the answer as rational number. So this is not a surd. And see in this question, that means biquadratic root of 625. Actually, I can write 625 as 5 into 5 into 5 into 5. See, the nth value is 4, and inside the root also we are having 4 times 5 has been repeated. So I can write the answer as 5. So this 5 is not in the form of surd. So this is known as a rational number. That's why this is not a surd. And the next thing is some points we need to remember in surds. Every surd is an irrational number. Yeah, we have seen, right? See, I'm having root 5. Then I can say this root 5 is a surd. So the surd is also an irrational number. But the vice versa is not true. But every irrational number is not a surd. So a better good example, see, irrational number, I can say pi as an irrational number, right? Whether can I say pi is a surd because it doesn't have hold any root notation. So I cannot say pi is an surd. So it's just an irrational number, but it is not a surd. But all the surds are an irrational number. So here I have given an example, pi only. And what is the general form of surd? Nth root of x, where n is called the order of a surd. This is also very important. They will be giving the surd and asking us to find what is the order of a surd. What is that is nothing but the value of n will give you the order of a surd. So we'll see some problems. for finding the order of surd. What is root 5? Root 5 means, see here, nothing is mentioned. If nothing is mentioned, it's nothing but it's a square root of 5. Then what is the order? It's nothing but 2. And the next question is biquadratic root of 8. So what is the order over here? It's 4. And what is this one? Cubic root of 20. Just find the answer by yourself. And the next one, what is rationalization and rationalizing factor? See here, this is very important. First, we'll see what is rationalizing factor. So what is that? I'm having two surds. See, for example, I'm having root x as one surd, another surd as root x. Just consider other surd is also root x. So when I am multiplying these two surds, when we are multiplying two surds, then if the answer is of rational, then if I got the answer as rational by multiplying the two surd, then I can say one surd is going to be a rationalizing factor of the another surd. And this surd is going to be the rationalizing factor of the another surd. This is what we are concluding. See here, there are two surds. What is the meaning of surd? It's nothing but an irrational number. If I multiply two irrational numbers, see here, this is an irrational number, multiply with an irrational number. So what is the possibility? We will get either the answer as irrational number or we will get the answer as rational number. So if we got the answer as rational number, then what it means, this both irrational number are going to be a rationalizing factor of each other. This is what we are specifying over here. See, I have given one example, which is 2 plus root 3 and 2 minus root 3. So if these both are irrational number only, because one is rational and plus irrational will give you irrational. And here also see, this is rational and subtraction is there in between and one irrational. So this also will give you an irrational number. So if I am going to multiply these two irrational number and I am checking whether I get irrational number, it is I cannot do anything with rationalizing factor. Maybe I got the answer as rational number, then this irrational number is a rationalizing factor of the second irrational number, and second irrational number is the rationalizing factor of the first irrational number. So we are going to multiply now. See, when you look into the problem, both the numbers are having the same terms, only the sign is different. So can I use an identity a plus b into a minus b? So what is the answer of this identity? It's nothing but a square minus b square. So I can write this as 2 plus root 3 into 2 minus root 3, which will give the answer as 2 square minus root 3 the whole square. So what is 2 square? It's 4. What is root 3 the whole square? It's just the answer as 3. So 4 minus 3 is 1. So 1 is a rational number. Then what we need to conclude? 2 plus root 3 is a rationalizing factor for 2 minus root 3 and 2 minus root 3 is the rationalizing factor for 2 plus root 3. So the process we are converting to irrational number by multiplying and we are getting the rational number, right? That process is known as rationalization. So we'll in this, we are going to check the given numbers are surds or not. The first question is root 180. 180 is not a prime number, so I need to do the prime factorization for 180. So if I do the prime factorization, I'll be getting 2 into 90 and again 2 into 45. Then I can go with 5 table, 5 nines are 45, 3 into 3. So I can write this 180 as there are two twos. It can be split into two twos, 2 3 and 1 5. And see here there is no number, that's the reason it's nothing but a square root. So we can pair the two twos and pair the two threes. So we will be getting the answer as 2 into 3 into square root of 5, which is 6 root 5. Yeah, we got the answer in a surd format. So I can say this is a surd. And we'll see the next question, which is 3 root 25. That means cubic root of 25 and cubic root of 40. Both 25 and 40 are not a prime number, so we are going to split this. So 25 can be written as 5 into 5 and 40, we'll check for 40, the prime factorization, 2 20 times and then 2 10 times, 2 for 5 times. So I can specify the cubic root of 40 as 3 2 into 5. So here see there are three 2's existing. So I can take 1 2 outside. So 1 2 I'm taking. So what is the left thing? 5 into 5 inside one cubic root. Another cubic root is holding 1 5. So we can combine all these three 5's because both are having the same root. So if I combine, I can take 1 5 outside. So the answer is 10. 10 is not a surd because it doesn't hold any root. So this is not a surd. We'll see the next question. It is cubic root of 64. So we'll do the prime factorization for 64. So what is 64? 2 32, 2 into 32 and 2 into 16, 2 into 8, 2 into 4, 2 into 2. So there are totally 6 times the 2 has been repeated. So cubic root of 64 can be written as 2 into 2 into 2 into 2 into 2 into 2. So there are totally 6 2's are there. So I can combine 3 2's together because it's a cubic root, right? So I can take for out of one group, I can take 1 2 outside. Out of second group, I can take the second 2 outside. So the answer is 4. Here also we don't have any root format. So this is also not a surd. Next, we are going to find the lowest rationalizing factor for the following problems. The first question is root 24. Check for root 24. Is it a prime number? No. Then we need to find the prime factorization of it. So 2 12s are 24, 2 6 are 12, 2 3s are 6. So 24 can be written as 2 into 2 into 2 into 3. So since it's a square root, we can take two repetition of numbers and we can take one number outside. So there are two 2's existing inside the root. I'm going to take 1 2 outside the root. The remaining is 6 inside the root. Now this 24 has been simplified to 2 root 6. Now with this 2 root 6, what number I can multiply so that we'll get a rational number. So I don't want this root 6. Then what we need to multiply with? Root 6 only. So what will be the answer now? 2 into 6, because root 6 the whole square is going to be 6, then 2 into 6 is nothing but 12. So 12 is a rational number. So what we are multiplying with 2 root 6? Root 6. So this is what the rationalizing factor for root 24. This is the lowest rationalizing factor. Then the next question is root 5 minus root 2. 5 is also a prime number. 2 is also a prime number. So we want to find the rationalizing factor of this, then just change the sign between the terms. That's it. So this is going to be the rationalizing factor of the question. Why we are writing like this? Because if I multiply this and this, what you will be getting, it is of the form a plus b into a minus b, the algebraic identity, which is nothing but a square minus b square. So if I multiply, I will be getting root 5 the whole square minus root 2 the whole square. Then what is the answer? 5 minus 2, which is 3. So I got a rational number as an answer if I multiply root 5 minus root 2 with root 5 plus root 2. That's the reason root 5 plus root 2 is the rationalizing factor of root 5 minus root 2. The next question, root 18 and root 50. So I do actually 18 is not a prime number, so we'll just do the prime factorization. So 2 9 and here 3 times, and 50 also will do the prime factorization. 2 so I will do with 5, actually it is easier, right? 5 tens are 50, again 5 and 2. So now root 18 can be written as 2 into 3 into 3, and root 50 can be written as 5 into 5 into 2. So there are two 3's are existing, so we can write it as 3 root 2, and here there are two 5's are existing, so I can write this as 5 root 2. See now 3 root 2 minus 5 root 2, both are root 2 terms only, so just use the coefficient and do the calculation and put the answer. 3 minus 5 is going to be minus 2 root 2. So we got minus 2 root 2 as a simplified form of what? This root 80 minus root 50. Now with this, what I can multiply so that I will get a rational number as an answer? I don't want this root 2. Then we don't want, then what we need to do? We have to multiply with the same root 2. So what it is going to happen? Minus 2 into root 2 the whole square is nothing but minus 2 into 2. So the answer is minus 4. Minus 4 is a rational number. So root 2 is the simplest, that means the lowest rationalizing factor of what? this root 18 minus root 50. The next problem is find the values of a and b for the following. So here the question is 3 divided by root 3 minus root 2, which is equal to a root 3 minus b root 2. We are going to find the value of a and b. So first we'll start with the LHS. See, in the denominator we have the root values. Always we should not have any root values in our denominator. If it exists, we need to do the rationalization of the denominator. For doing the rationalization of this, we have to multiply with the rationalizing factor. What is the rationalizing factor for this? It's nothing but root 3 plus root 2 divided by root 3 plus root 2. We are going to multiply both the numerator and denominator with the rationalizing factor of the denominator. So now we will simplify this. What about the numerator? It's 3 into root 3 plus root 2 and divided by, now in the denominator see, it is of a minus b form and this is of a plus b form. Then what is the result of algebraic identity? It is a square minus b square. Our a is root 3, so the whole square, minus b is root 2, so root 2 the whole square. So what we will be getting as an answer? Just multiply this 3 with the root 3, it's 3 root 3, and multiply this 3 with the root 2, so it's going to be plus 3 root 2 divided by root 3 the whole square is 3 minus root 2 the whole square is 2. So the answer for the denominator is 1. So 3 root 2 divided by 1. So 1 means I can write just like this, 3 root 3 plus 3 root 2, which is equal to the RHS. What is our RHS? A root 3 minus b root 2, which is given in the question. See, the first term it is root 3 and here also it is root 3. Then what is our a value? We can combine these a value. So what is the a value? It is plus 3. So what is a value? It's nothing but plus 3. And see the next term, this is also root 2. This term is also root 2. We are just comparing the coefficients of the terms. And here it is plus 3 and here it is minus b. So I can compare plus 3 with minus b. Then what is b is equal to? B is equal to minus 3. So we found the value of a and b by doing the rationalization of the LHS. So the answer for a is plus 3 and answer for b is minus 3. Thank you.